Today is the March 21st, 2023. This is a Kepler bi-weekly community meeting. So we have an agenda today to discuss the recent progress in developments and the issues we faced on GitHub. And also because this is second last meeting before we close the 0.5 release, we want to decide what will be included in this feature and what will be planned for the next release, 0.6. So let's just share my screen first. By the way, if you have any things on top of your mind you want to discuss this morning, feel free to add to the agenda or just post on the group chat. You can also share your screen. The share button is open to everybody today. All right. So from outside, the Kepler developments, we have two releases. One is the operator. Is I'm just open it up to the Kepler repo. So the Kepler community operator is already posted on Operator Hub. So if you look at the PR here, okay, maybe it's not on this. The pull is not actually on this one. Most recent, I think this was merged yesterday. Give me a sec. This is hard to find. I should have prepared the link today. I think the idea is I just want to show you what's the PR look, what's the operator look like. And Peru previously had a recorded demo of using the operator from command line. But with this operator as the operator hub, you should be able to install operators through the UI.
I mean, I searched in this repo seems to PR related with Kepler being merged. So is that means Kepler being officially announced at OCP?
So we have a different deployment model. The operator model you can use this on Red Hat OpenShift. So as well, I think you can also use in the Kubernetes. I haven't tested either of the case yet. We should have better ideas, but he's not here today. The second way is the Helm chart. So we had recently people from Red Hat testing the Helm charts as well and find out there was an issue over there. And also we have community involvement on using the Helm charts. And Peng Hui is another issue regarding to the size of the CI. So both of these approaches are accepted. The manifest is the last way. That is used mostly by the developers. This is also used in the CI. So for anybody who's working on Kepler ecosystem, working with the manifest is the preferred way. That will catch up most of the recent changes. But at the end of the day, for people who prefer to use the Helm charts, we have a chart available, and operator for internally and for people who are using OpenShift and potentially Kubernetes, operator is yes another way to help you to install the Kepler and the related manifest. But to the question, yes. For Red Hat products, if you want to be support open chips, you have to have an operator. The second is
Okay.
any questions so far? I think
No, please go ahead.
going to the playlist. Peru has I also included the Peru's operator demo. We plan to release yet another demo how to use the operator from the operator hub when Peru is back. So the standalone Kepler means that we run Kepler as a standalone binary or as a standalone container. So right now we support both ways to install Kepler on Linux, with or without containers. Because I do not know much about Debian package. I only have RPM package right now. If anybody want to use using Debian, you can have the package in certain ways in that way as well. So we have the RPM package. So the two ways Kepler are packaged as if one way is as a Podman container. So this only requires a systemd units. So we start Podman and we run the contain the latest container image, and we set the necessary environment variables and months directories in Kepler. So that's the simplest way. If you do not have Podman, the binary way is we build Kepler and we build the binary and release the binary in the RPM. So the binary is also managed by the systemd unit. If you know how to build a Debian, you feel free to have yet another release here. And we also have Kepler in the release package. So when we release a package, we also release a Kepler RPM manifest as well as the source code. So this is what we have recently, and Sam, do you want to show what we have done on the multi-arc course, the dark image, the post x86 and ARM, and potentially 390?
Yeah, so for multi-arc support, so currently I'm starting to build the image and we have PR there. So in fact, somehow two things found. Okay. So the first item is that for Linux kernel. So as we all know that when we build Kepler or say prepare for the base image, we will need the Linux kernel. So we're going to do something as yum install the kernel developer mode there. But unfortunately on GitHub action, we found that the OS version is not kernel with some specific number, but kernel with Azure GitHub specific version. And obviously this kind of yum package cannot be found because Azure use Ubuntu as their base OS. So well, so all the build will failure with kernel development. This is the first thing. And the second item here, I try to remove the base ARM and the base 390 there, use a single base image inside. So this will change, or say going to change the base image for 86 from Navida 1 to the general Red Hat image. In my point of view, so first Navida provide their RPM package there. So we can either install from Docker pre-prepared our package from their officially distribution. And second is that if we install the specific hardware device support by change the base image, so in the future when we try to add further device support, we will facing an issue that we cannot from two base image, right? So in my point of view, I would like to suggest that we use a common CentOS or Fedora, etc. image as our base image, and for any kind of hardware support, we install the driver something from a YAM package. But for the GitHub action one, currently I don't have good idea. So that's it.
Yeah, thank you for the updates. So just for the background, previously the base image is built offline. And this is for two reasons. One is that the base image is actually takes a long time to build. It's collecting so many package. The updates, the YAM updates will take a while, and the installation of the many of the packages also takes time. I do not want the CI to be blocked by building the base image, so that is always built offline. With GitHub Action to build the base image, we have to support different scenarios, different platforms. So that takes a lot of time. The base image and the build image. So I think this may not be right. I think the build image can be the same one. The base image can be platform dependent, but the build image can be the same one. So as long as we are using the right Golang binary to compile cross compile the different targets, we should be safe. But that's TBD. I may be totally wrong. So finally, we have to release Kepler multi-arc image to support multiple platforms, cross compile and support multiple platforms. So this is something hopefully we can finish for this release, and we can use this in the 0.6 release. This is one the last item I want to have in this release. Anyway, let's just have a little. Yes, go ahead.
Oh, okay. So I suppose currently we just keep this PR open and let everyone test this PR first offline. After we ensure the PR works and good with all the platform, we can maybe merge this PR first. And the second question is that this PR is targeted to the base branch, and so which means we should consider don't maintain two branch, so maybe we should have another PR from base branch to the main branch, and yeah.
Okay, that's also reasonable. So if we just merge it to base branch, and the risk is very low, so we can always merge it and then let people test it. Once it's ready to release, and then we merge it to the main branch. That also works.
Yeah, and I also agree we can put it in 0.5 or 0.6 for our release plan. So because as we could not build the base image and the builder image through GitHub Action, so it will take us a lot of time to confirm the base image works for each platform.
That's good. So yeah, something related to the packaging is that there's some use cases people want to use in Kepler in this real-time kernel. So as you know, there's a real-time Red Hat Linux, and there's a real-time OpenShift. That's also using the real-time kernel. The real-time kernel is actually have difference. So explain one among other things, have a different way to using the kernel headers. So that's we are also introduce some of the changes to the base image build. So we will to investigate that process later. But just keep in mind the build process may change from time to time, depends on the use case we want to support. So we have a Renjie from Intel. So one of the things I really want to have help from Intel is the platform support. The idea is right now the models are very specific to the microarchitectures different platforms have. So if you build a model for example, if we have a model for, I'm just go to the, if you have a model for one of the microarchitecture, the model is only used, is most likely just to be used by that microarchitecture. But if we have different architectures to run, sorry, this is not the one, then we are in trouble. So let me just explain what the models, the structures is about. So the dynamic components model weight is the models that's supposed to different components, the CPU package, the CPU core, and the CPU and the memory. So we use different features to calculate the energy by each of the components. The models are trained on the platforms that will target the runtime environment. As we see here, we have the CPU cycles and CPU instructions and let's see what else, cache misses. So these are so far these are three features we use in the eBPF to get from the hardware counters. We're probably going to add more counters in the next release, just depend on what the research will show to us. But we test difference for certain reasons. This one does not have the CPU cache here. Maybe I just read the environment. Or maybe the security architecture is already gone. So I will come back to this topic later. I will check with Karen. So she's not here today. Previously when we trained models, the models were attached to each of the CPU architecture. So since this one is not here, then I will skip.
Yeah, thanks, Huaming, for pointing out this. Yeah, this is Jiren from Intel. And actually, this is the second time for me to join this session. This is a bi-weekly meeting. Yeah. Nice to meet our team. Yeah.
Yeah,
actually, we Intel is getting very interested in such model designs, and we are also exploration on the maybe the related power modeling for our Intel's hardware accelerators.
Okay.
We are seeking for opportunity to contribute to this area in Kepler. Yeah.
Okay, that sounds good. Yeah, so in point 6, we have some ambitious plans. I don't know how much we can execute. So top of my mind, I probably can list this here. So the top of my mind is that so the training. So far we support the so-called integrated power meters. So we read the power from the CPU package by the instructions or by hardware sensors, but everything is still within the same compute node. We do not have access to the BMC. So BMC has have more power have a more comprehensive source of power meters than CPU can have. So we want to, if you want to use, for example, the network card, the storage, BMC will just report everything in aggregate. So this is both opportunity as well as a challenge. Opportunity is that if you want to know more about the activities, power consumption on different activities, the BMC power meters probably is a better source. The challenge is that it does not have the granularity as the CPU package, and it does not distinguish whether the source power is from the CPU or from the storage or from hard drive. So we will investigate how to get the components, more components power from BMC in the future. And I have read a lot of existing projects and research papers, but I do not see any of the clear answers to this question. So hopefully we can start this investigation in the 0.6 release. And also see Bertrand here. So Sentry has a hardware sensor that can read a lot of information from different sources. Potentially, we can use in this Sentry telemetry data on different component sources and how to aggregate and distinguish different power sources and to have a clear picture of which components using how much power. So this could be a broader discussion starting from 0.6. And let's write it here. So
Okay.
I would say,
This is Bertrand. Yeah, I would be happy to participate into these discussions. Yeah, because some of the questions you've been asking, we try to answer these questions, like collecting parametrics from different types of systems, and breaking up the different components, the power used by the different components, like GPU, network card, storage, fans. Yeah,
right.
yeah, the fans too, etc.
Yeah. So the idea is that we probably going to use the external power source as either as the training level or as the inference level, and using that information for identifying the component level power consumption. So we will come up with the design in the next release planning meeting. I'm going to send us the invites after middle of next month. To time that we all can sit together. I think probably we'll have two design meetings. One is just for the external power source. The other one is going to be for the performance and scalability discussion. So we will start that discussion in next release. Most likely to the end of April, either end of April after KubeCon or just end of May after the open source summit. So the timeline is not decided yet, but just keep in mind of next 2 months, we are going to have the discussion to decide how to support these 2 years. Let me also rest down this one as well. So for the scalability issue, currently we're using the Prometheus clients. The problem with the Prometheus clients that is not scalable. If you want to see, there's a good discussion we had on the other side. And many of the people from Kubernetes SIG instrumentation and also from Prometheus, they share some reasons why this is a problem and what we can use for other projects examples to help us to make the Prometheus client more scalable. We're hitting the scalability issues already. So if you are turning on the Kepler process metrics, and if you have lots of active processes running your system, and each time you scrape the Kepler's endpoints, you will see the CPU just spike. That shows something related to Prometheus client API. It's not scalable when we have a lot of metrics to export. So we want to have an answer. As this, that's the investigation next release.
This is Bertrand again. So, will you be considering OpenTelemetry as well instead of Prometheus? Maybe that could help.
Yeah, I think the issue the problem will be similar, if not totally different. We had this is not in Kepler, but we had used in the other projects in Rook, and when the telemetry tracing is turned on, the performance will hit quite a lot, actually by 10%. So based on that experience, so we want to see what should be done in Kepler side and what should be done on the Prometheus or telemetry API side. So we can have good answers for both. I think certain things have, like just certain things in Kepler has to be optimized. Like we should use more caching and using more static data type and reduce the memory fragmentation. These are things we should be optimized in Kepler. Once we figured out everything in Kepler side, and then we look at the API side, either the Prometheus API clients or the telemetry API clients, and then we decide what we are going to use eventually. But the answer to that is definitely yes. Yes, we will consider both cases.
Awesome. Thank you.
Yeah, thank you for your help.
Yeah, I suppose. Yeah, I suppose for this one is an open question. So, personally, I feel like this question, like, we have number as m for matrix and n for pod there. So it likes m multiplied by n size problem. And as we, as a exporter, and we make things in some interval, so each turn we refresh the data. And so personally,
Yeah, so that could be also be one of the solutions. So let's see, we have to investigate
Yeah, so
using certain benchmarks. So we developed tools to find out where the bottleneck is, and trying to resolve the bottleneck as much as we can. If we cannot resolve, then we change the API. So that's my 2 cents on top of my mind.
yeah, I would like open to any solution, no matter open telemetry or Prometheus client enhancement, etc. But
Okay.
I suppose, yeah, I would, I have a personal plan to try to build a benchmark, try to reproduce what happens through some benchmark code there. I will update for anything found there, but still don't get the enough bandwidth to take action on this.
Summer is the time. We can use the summer as much as we can to improve our productivity. So let me just have one more thing on top of my mind. And if you any of people here have anything you want to add to the agenda, feel free to do so. So for the modeling, for the Kepler model server, if you look at the existing models, we have mostly linear models, gradients, linear, rather that is a linear regression, gradients boost, and there's a Keras models, but that's why it's not so heavily used because I do not have a good ideas about the inference overhead, so I have not asked Pen to put this into production yet. So we also have the XGBoost models that Kai has created. So in the next release, I hope that we can at least push all these models into interaction. So many of the models are already built, but are not used very often. Either people don't know how to use them, or we have not had any of the manifests to support them. So starting from the next release, we are going to use at least we are improve both on the usability experience as well as documentation. So each of the models will have its own documents, what's their use cases, what's their overhead, and what's their accuracy. And the manifest to using these models and the use cases and the environment use cases that's using these models will also be provided, so people know which model they can choose and how to use them to maximize the accuracy as well as reduce the overhead. So this one, I also want to get started in 0.6 to improve the usability and the exposure of these models. And obviously, the more we improve the visibilities, the more models people will share with us, so the more likely we are going to have better and more models in the future. So these are the 3 things I want to make sure that we can at least in the next release. Do you have any suggestions? Or I want to get some sense how much efforts people want to put into any of these items in the next release. So the next release, I think, because this is a summer, so I think it's reasonable to using like this 0.5 release. We use the 4 months starting from late January until mid of April, so we can consider like 3 to 4 months. And the next release, because it's going through the summer, so we probably going to cast a release at close to the end of the summer. So we start the planning in April and May, and then we have the release in either August or September, depending on obviously the people's bandwidth and how much we want to do in this release. So that's a tentative schedule in our mind. If you think you can do something in the summer and you want to have some certain things to deliver, just share with us your availability and the task you want to take on, and we will start from there. Anything anybody want to add here?
I want to ask a question. I mean, so for coming SenseF review, what should we prepare for it?
I'm sorry, I just missed the question.
Yeah, sorry. For commune CNCF review, so maybe the CNCF review time
Oh, okay.
window open in May. Yeah, so
Yes, in May.
what should we do? Yeah, so anything need to be prepared?
So I do not see anything else we can do here because in my observation, the CNCF board, the technical oversight board, is refreshed recently, and more new members are just added in March. So it's probably going to. This probably is it's quite true. There are lots of activities in CNCF PLC at the moment, so the review may take longer than. Also, there's also a lot of projects in the pipeline to be reviewed. So the review may take longer than I previously anticipated. So it could, the next review cycle is in May. So we could get reviewed in May, or we may miss the window and we will wait for yes another quarter or so to be reviewed. But that does not change the direction we are going to. We still stay with CNCF. So whether that is in May or later is just a problem of timing. The other requirement, I think, for the CNCF sandbox application is the more ecosystem interaction, the better. So we will work with different CNCF tags. We have arrangements with the runtime tag to show Kepler, how Kepler can be used. For example, the GitOps. So that is something we can do. And maybe we can also work with other tags to show what Kepler can do for the ecosystem. By the way, since we are talking to the interactions, so we have a few publications coming in the coming months. So in KubeCon, there's going to be some discussions about. There's going to be some talks around Kepler. We will show how Kepler can be used for the CNCF projects and for the ecosystem and also for sustainability. So we'll open source summits in North America. We will show how Kepler will be used in different environments. So let's see how much we can receive from the community. Thank you.
Oh, okay. We will waiting for any news on this.
Yeah. Hopefully we can get something positive very soon. All right. So if you do not have anything to add, I will just give the 25 minutes back, and let's think offline as the Slack. All right.